We've got some more sessions now between now and lunchtime. And the first one, I think, has got one of the most tantalizing descriptions. Paul Stack, I scrolled down and it says, we'll cover why we made the decision to stop writing code. I'm just going to stop there. I think that sounds excellent. Let's all just stop writing code. I love that idea. For those of you who were here earlier where it was really, really busy, we've got some more chairs we're going to bring in at lunchtime. So when it gets busy later, there'll be plenty of places to sit. Do not worry. But I'll hand over right now because Paul is here to talk about why he stops writing code. Thanks, Paul.
For the people on the live stream, the room is absolutely packed. It's not, don't listen to what I say. I'm joking, I'm kidding. Okay, so my name's Paul Stack. I am here to talk about that if humans architect the system, then the AI writes the code. I want you to give me 25 minutes, that's all, and I'm going to show you why it doesn't matter about code anymore. Code is not actually the thing. And just before I joined the stage, I kicked off a process, which is our process of how we actually author systems within our company, and I'll show you the output at the end. So we do not write any single code. Okay, not a single line of code have I written since, I don't know, maybe end of January. This is how we work. This is how I work. I'm not here telling you this is how you should work. Trust me, it's very liberating when you don't need to care about the code anymore. But I promise you is like a very interesting direction and a very interesting way of going. I'm going to show you our process in detail. And you can take what's useful. Everything I'm going to show you is open source. You can play around with it. You can have a look at it. You can see what craziness is in there. But by the end of it, I want you to think through like the types of things you can do. Okay? The distinction here is between writing code and building the machine that writes the code. Okay, in the AI era, that's the very interesting thing. We hear it called software factories, dark software factories, all these different things. It all boils down to a very similar thing and a very similar process. So what we're going to cover here today is why we stopped writing code. Okay, what changed when we did, how we designed guidelines, what does our architecture first pattern mean, how Swamp, I'll talk to you a little bit later about that crazy name, and how AI gives you back the work that we actually got into the industry to go for here. So the bottleneck is no longer thinking in software. Okay, it used to be that we had to think about, how we took an idea, how we pushed that idea through to users, how we tested that hypothesis, and the time scale to do that was a huge amount of investment, and we had to sink a lot of upfront thought and process into it. Okay, at the company I work at, previously, it was called System Initiative. Just last week, we spun up a brand new company based on the back of this, and it's called Elder Swamp Club. At System Initiative, we spent 6 years building a product. Okay, we were trying to revolutionize infrastructure as code and the ways through of infrastructure as code. It was the most beautifully, and I really mean it, the most beautifully architected Rust code base that you've ever seen. Okay, it was an incredibly well-designed distributed system that ran many microservices that talked to each other through event buses and did a lot of stuff. End of January, we threw every single line of it away. Every single line. And it's not because the code was bad, it's because the product we needed to rethink for the agentic era. The product wasn't going to resonate as we went into AI and pushed forward. Now, unfortunately, we let the team go at that time, and 5 of us stayed behind. 5 of the whole company stayed behind. And on January the 25th, we started with a Miro board with not a single line of code written in the entire system. We were like, right, let's redesign something from scratch and think through what we actually did. This slide, I originally first gave this talk 2 months ago, and I said 2 months, absolutely thrilled by what we have. 4 months, I'm blown away by what we've built. Okay, and I genuinely mean that, not because I've built it, but because I've actually built a product that I've always wanted to work with as an operations person. Yes, I am an ops person, a developer. I've been writing code for a long period of time. And so I have a very big interest in what we're actually trying to build here. I worked at HashiCorp building Terraform. I worked at Pulumi building Pulumi. I've worked in the developer tool space for a while, so I'm incredibly opinionated. Incredibly opinionated. So for me, it's like very important to build something that I really care about. So the question is, if I'm not writing the code, What am I doing instead? Actually, it's even better, okay? I fell out of love with code maybe 2 years ago. And the reason I fell out of love with code is because I was on a Zoom call with 5 other people, and they were talking about the naming conventions of NATS queues. And I wanted to like lose my mind, okay? Least interesting thing in the world for me personally. The people I was on the call with loved it. They were so intrigued by it. They really wanted it to be perfect. I didn't care, okay? I just want to point out something. I'm from Northern Ireland. If I swear, it just happens. I don't even realize it just slips out, so I apologize in advance, okay? So for me now, what I actually do is, even though I own the product, because I'm like actually like the person responsible for it, but I actually own the architecture that goes with the product. I care about the design decisions, the constraints, the invariants, the things that sort of make this system coherent for a user across time. The engineers are getting consistently good output when they actually express what they want architecturally. I wrote a blog post about this maybe 3 weeks ago called "The Vibes Don't Scale." Okay, it doesn't. Okay, TLDR, the blog post, they don't scale. Okay, if you're vibe coding and there's no idea of what you're trying to do and you give it a single line prompt, you're going to get somewhere. Is it going to be the most secure, the most useful tool over time? Probably not. You're going to have to invest some serious time, and you're probably spending a lot of tokens in order to do it. So for us, we try and make them specific, unambiguous constraints, which means we banned handwritten code. Absolutely banned it. We cannot, none of us as engineers or people that work in the company, we can't send a pull request when it's written by us. It'll be deleted, removed, won't even be closed. It'll be literally just deleted as a pull request. It's not a guideline, it's not a preference. It is literally how we do things. Agents write every single line of code. Okay, you can go to our repo. Even though agents write the code, I promise you it's not awful. I would like to say it's great. It's not. I mean, there's going to be things that you'll look at and go, I don't like that. I don't like how that's laid out. That's taste. Okay, that's the least important part of it, naming conventions. How many times have we argued on pull requests as software engineers over naming conventions and how many lines should a class have before it's refactored? I once heard a ridiculous, absolutely ridiculous conversation where somebody says, if a class is over 100 lines, it should go into its own microservice. I'm like, come on, this is stupid. This is absolutely crazy. Okay, so for us, it's much more about the fact that we give the LLMs, our agents, very strict operational and design guidelines. Okay, that's what we work on a day-to-day basis. We work on the system design. We work on the constraints that the agent has to work within. We work with all of the pieces that the agent has to form really strict guardrails about. These are the patterns, the boundaries, the architectural constraints, the invariants that we must hold, things that have failed in the past where you need to feed that data back in so the agent doesn't make that same mistake again. Because you know what? Agents are bad. They will make mistakes. Actually, they'll tell you they haven't made a mistake, but they absolutely have made mistakes. So this is not for us documentation. This is actually executable constraints. And this is what's really, really important. Okay? Also, because we don't write code, we don't accept anybody else's code. We are an open source tool. We'll talk about that a little later. I believe truly that the norms of open source are now changing in an AI world. So many projects are being overwhelmed by AI-driven tools, by AI-driven code that is going into the system, and they're just not willing to maintain it. So many people have built tools around this in order to stop it from happening. Mitchell Hashimoto created a tool called Vouch, okay, where you actually have to vouch and say that you're not an agent and that you actually, you're the right person that's like sending the code. We don't accept any pull request in any way, shape, or form. And it's not because I don't trust your code. I absolutely do not. But what I am trying to do is I am trying to maintain the integrity of our supply chain. Okay? I have end users of a binary. The last thing I want to do is to try and open an attack surface where somebody who is inevitably smarter than me will be able to inject code into the system, and you see so many of these problems happening all over the internet today. Okay, Trivy got absolutely destroyed a couple of months ago. Okay, we saw a mini Shai-Hulud attack last week where 364 NPM packages are actually at risk in the system. So, we're very much a case of AI will generate really plausible, well-formatted, tested code at scale. And if we have to author and look at that code, we're never going to be able to distinguish what is a supply chain attack versus what is actually a change in the code itself. So we just banned it. Okay. And sure, we got a lot of pushback from people. They're like, oh, that doesn't really seem great. I absolutely will accept you driving our product forward. Give me issues. Give me feature requests. Give me design specifications that you think are more interesting. Give me ideas where the code is not great, and the system will actually help drive it forward. So for us, we have a full flow from idea to merge code. And our flow looks kind of like this, okay? So we have a start, and you triage an issue. Okay, we actually wrote, funnily enough, we're in an AI world, we wrote a skill. Okay, everybody's writing skills. Our skill is backed by a CLI. Okay, our skill is just Guardrails running the correct CLI tools to do it. But effectively what's happening here is we triage an issue or a feature request. It then gets classified. It then goes into a loop of plan-generated review, plan-generated review, plan-generated review, and that's an adversarial review. Okay, so it's great that a plan, an agent will say, this is the best plan for what you do. Then I have written a very grumpy adversarial review that says you don't trust any code in the world. You have to prove that it's secure. You have to prove that it has no injection attacks. You have to prove that it is architecturally complete as to the guidelines. And these two agents basically go into this loop to figure out when it gets to the right thing. We get to 5, okay? We'll only ever allow 5 loops before it steps in and says, hey, we can't agree on this. You have to be the arbiter of what's going on. At that point, I have to step in. Human is in the loop now at this point in time. Plan is generated. Plan is secure based on an adversarial. Human has to say, this is the right feature. This is the right bug fix. Here is the reasons why. We then start implementing it. After an implementation, we recreate it. If it's a bug, we try and verify it. If it's a feature, then it goes into pull request open. Pull request open goes through another set of reviews. If it's failed, then it goes back into implementing and so on and so forth. Then we go into release it, and then we notify the users who requested it, and we're done. Okay, this isn't a whole pile of shell scripts because that would be horrible to maintain. This is actually basically a state machine inside a skill and a CLI. Incredibly simple, but actually incredibly powerful because I can extend the state machine in any way, shape, or form. For us, the entire entry point of the system is our Claude.md. Yes, we are Claude code users, okay? Agents.md, you can swap in and you can do the same thing. For us, it's Claude code, okay? It is the executable contract. It is literally the center of gravity in our entire system, and therefore, every Claude code or CI session will read that Claude code by default. Now, our Claude code is slightly different. We don't embed all words. We're not good with words. We're software engineers. We have things like this, okay? TypeScript, it must be strict. No any's, because any's are the devil. It must be named exports, no defaults. It has to be AGPL copyright on the top of every file. No fire and forget promises. Don't lose people's memory, right? Then architecture, everything has to have log and JSON endpoints. Everything has to import from mods. You should never leak internal paths because that's an implementation detail. These are the types of constraints that we care about, okay? These are the types of things that are very, very important. And then there's always a line at the bottom of our Claude code that basically says, hey, if you hit a non-obvious problem during a session that is going to trip up future users, future Claude sessions, future agent sessions, record it and propose an update to your Claude.md before we continue. So when we go in then, we go into a complete testing strategy. We have unit test, integration test, contract test, property test, architectural tests, and that's the end of the binary. Once the binary is built, we then take that built binary and we ship it across to a different repo. We take it completely out of the context of everything else, and we run it as a user. We run effectively old UAT tests. Run this script, here is the intent of what it's going to do. Run this command, here is what it's going to produce. Never like hard-coded for words, that would be crazy. And then we have another set of tests that sit on top, adversarial tests. Okay? Those tests are, try and inject it. Try and kill the process in the middle. Try and kill the data. Try and remove it. Try and do everything that a user will ultimately do. Not by mistake. They just do it, and that's just what happens. A user is your best user, your best QA of your entire system. We try and treat those bugs that come in, and we feed them back in to be adversarials. Then our CI takes over. CI for us actually has 5 merge gates. Okay? We have our code review, because we need a code review. That's just the way it works. But then we have an adversarial review. Assume everything's broken. Try and prove that it's broken. Then we have a user experience review. Check the CLI. Make sure that it doesn't regress the output. Make sure that the commands are the correct structure. We try and go noun, verb. So we try and keep that sort of, thing create, thing get, et cetera, et cetera. So we try and ensure that consistency, and we have to encode that as a review step. Then, of course, we need a CI security review, because all sorts of cheeky people, they're going to be trying to inject stuff into my CI pipeline, so I want to catch it before it even starts. And then the last one, which is amazing considering where we are and everything Guy said, is for us, skill checks are incredibly important. Okay, not just the actual skill, but the content, the format, the layout, the triggers. That is a hard gate for us. Our system is incredibly set up to be driven via an agent, so therefore the agent experience must be really good. So we literally will block any regressions in content or experience as we go through. When everything passes, it merges itself. I'm not kidding, okay? The reason I'm not kidding is if I show you, this pull request merged just before I got on the stage. And you can see the pull request was opened by my agent. It had the first review. Then this one passed. Then it goes a big old blocking review. Like, can't do that. Agent then figured out that it had to push some changes. Right here. Keeps going. This is all context. It's incredibly important. There's the new change. And the agent was actually able to go and reproduce itself, figure out that everything was fine. These suggestions are all OK. And then it auto-merged itself and kicked in. Okay, we're not doing anything like out of the ordinary here. We're just trusting a process that we continually hone in that process. So for us, the gate is our UAT. Just because something is merged doesn't mean it automatically gets to an end user. We have this whole level of tests that go through, and we catch regressions every single day before it goes to end users. Absolutely every single day, and it blocks our pipeline, and nobody else can publish a release out there until that's fixed. Now, the most important thing is here is in our UAT repo, we have a line that says the tests are the source of truth. Don't change the tests. Always figure out if it's a regression in the binary. Okay? And what we've ended up with in the last 30 days is 295 issues have been opened, and that's issues, not just bugs, but feature requests, etc. I shipped 217 of them. I closed 81 as either duplicates or just not things that we're going to do. The median time to triage, this is not work hours, this is like elapsed hours in a day, is 4.6 hours. And from triage the whole way through to shipped, including all of those gates, is 1.6 hours. Okay, there's 5 people at the company I work at. Each of us has a Claude Code Max Pro, which is $200, and then we spend about $1,500 to $2,000 per month on the whole CI review process. We're able to ship software many times faster now for $3,000 per month than we were ever able to do before. It's really not that. But what we've actually managed to do is we've taught the system to debug itself. Okay, so Swamp actually knows when it encounters an error, it will check the source control of the code out at the version that it has the error at. It will try and reproduce the error, and then it will open an issue on your behalf. It will even check if the issue has been fixed in a later version before it happens. So we're trying to include this guardrail in what we're doing, and we end up with this like really tight loop with bugs. which means the bugs that we get from the agent are incredibly well formed, and they have a lot of great context that goes with them. So for us, we're not really just automating code. We're actually building the whole system that keeps the system running and keeps it going. And what we care about here is we don't need a bus factor anymore. We all work in teams where one person is like the overarching architecture person who you know you need to go to ask about the part of the system that hasn't been changed every 6 months or every year, okay? We do it in infrastructure as code, we do it in platform, we do it in actual software all the time, okay? We're trying to remove that bus factor because we're trying to make the agent aware of the system. An agent is in a fresh context every single time. In the past, I don't even know how long, maybe 2 months, I've not had to run /clear on my context window, okay? Because every report is a brand new Claude worktree, which keeps it very focused, very specific, and it means that it actually cares just about the context in that area. So how can you get started? Okay, because that's the whole point of why we're at a conference like this. Okay, the smallest possible way to do this, and I talk to so many people about this, okay, turn your conventions into constraints. Okay, sit down and think about the constraints that right now, if you put an agent on a piece of software in your source control, that it doesn't know, it won't be able to get from the source control itself. That's the first thing that you can absolutely do, and those constraints are really important. Encode that one thing that only one person in the organization, the software and IT organization knows. Okay, because there is definitely one in every org, 100%. Okay, run that loop once, end to end. Figure out where it breaks, and that's the next constraint that you have to go. You always have to start really small and just fine tune. You just can't push an agent at your entire source code repository and just imagine that things are going to be great. It will not be. Okay, it absolutely will not be. But if you do this right and in this small, controlled way, what ends up happening is that AI is going to give you back the work that you got into the industry to do, solving user problems, generating systems for end users, having architecture and systems design. I blogged last week saying the words intent is the new architecture. Both previous sessions in this room, Guy's and then Dana's, was a great reflection of exactly where people are going in that respect. And I loved seeing both of them because context is the new code. And Dana started talking about the fact that intent is how you drive the system going forward. You can see that a lot of us are starting to come to the same agreement, the same consensus about what is actually happening here. So, as I told you, I kicked off a swamp image triage before I started this talk. Okay, I started with the command at the top that says triage issue number 518. It loaded a skill. It ran a couple of commands. These are actual swamp commands. These are our CLI commands, which set up the guardrails for the system. Then what it does is it fetches the details of the issue, starts to understand the code base. It's starting to read the operations files. It's starting to read all of the context that it actually needs. It then brings me back a list of summary of findings. Here's what I found. Here's what's happening. And then because of that, it can classify it. And it can basically say, hey, this is a bug. I have everything I need to write the plan. Then it builds a very structured plan. And because it's a very structured plan, it's actually able to give me a really detailed output of what the plan is, plus any of the adversarial warnings that are happening in there. Okay? This is not, honestly, when I say this is not like super smart, this is just building guidelines and guardrails. This is actually what I'm talking about here. Where is my screen going? Yeah, there we go. So it's really important here that what we're in a situation of doing is creating this setup, this structure, this different piece that you need in order to build this factory, this system that allows your system to be able to drive forward. Okay? And then, like, for us, we built it in Swamp Club, so swamp-club.com. You can go and have a look at how we've built it because, as I said, every single thing here is open source. all of the issue triage, all of these pieces, all of these factories are all open source as well. So for us, we love being able to show this off. This is like our pride and joy at this moment in time because we're having such a great time building the software that we are. You can find me on the internet at Stack72. I've written countless blogs over the last 4 weeks about how we built this, and it's at stack72.dev, and I believe I have some time for questions.
Thank you. Do we have any questions? Right there is a super convenient one. Louis, if you wait for the mic, thank you.
Hi, that was a great talk. Thanks very much. What's your bottleneck now? Is it like, because you're running this on Claude Max or you're running it on your laptops, is that the bottleneck? Do you wish you could put this on the cloud or like?
Wonderful question. What's our bottleneck? The bottleneck is deciding what to build. Okay? I don't run autonomous agents that sit and triage every issue coming in. That would be madness. The reason it would be madness is that somebody is going to inject something. So there's always a human that looks at it. Is this worth triaging? Is this something we care about? That's the thinking now is actually deciding what to build. Because when I can build so fast, I can spin up 10 agents at the same time, but if it's the wrong features for the users, I'm just going to create this monolithic system that doesn't really make any sense and has no sort of drive and no consistency going forward. That's our bottleneck. Our bottleneck is now thinking through what is important for our users.
Nice. Any more? Louis? Over there. Can you wait for the mic?
Well, that's probably helpful. You said with the your system, the lifecycle review, that it's automated until sometimes something gets flagged where the agents can't agree, and so therefore that's when the human comes in the loop. When the human comes in at that point, how do they gather enough context to be able to decide, which way to go? Because the agents have been churning so much knowledge that probably there are different ways depending on the context, but how do you start to sort of figure out, all right, how do I gain the knowledge?
Wonderful question. Okay, so the question is, how do we as humans arbitrate when the agents are actually not able to agree? So for us, it's like every time we run that command, that plan, that adversarial review, that's captured as structured output within our own system, within Swamp. So we can actually use Swamp to query it and say, hey, give me the 4 things it can't agree on. Tell me where it can agree, because all it is just data, right? It's literally just data where we can actually ask questions, and we can because it's so easy to understand the difference, and then we can make the decision. And if at the end of that we can't make sense of it, we go right, kill that session, start a new one up, because we've only lost like 10 minutes, and there's no issue. We're not spending thousands of dollars. I mean, it's literally a very short period of time and able to do it, so we can spin up as many as we actually need to.
Could you expand a little bit on your open source model, and especially the commercial model? I'm a big fan. I completely agree that we are reinventing how open source works, and I like your approach there. But what's your commercial model of it?
Okay, so we're in the business of selling software licenses. Okay, that is literally it. It's like a Red Hat model. Okay, and the reason it's that way is because people now care more about supply chain, and they care more about the maintainability and the drive through that. So if somebody wants to take our software, fork it, build it, do whatever they want, go for your life. It's AGPL v3, right? It's the way it works. You can't build a competing company because that's in our terms of services. But at the same time, we are actively working with a lot of people who want that license, who want that care, that maintainability of the software. They don't want to have to maintain this themselves. That's our license model.
One more quick one.
Do we have time? Okay.
Thank you. Thank you so much for this talk. I think the question that I have, I'm sure that you still 5 people in this team right now, right? Is the approach applicable on large scale build, when you have like hundreds of microservices and challenge to scale and domain expertise?
What a wonderful question. Is this approach scalable to other people? Dana said it really well in the last talk. When you have a guardrails in place, when you have this system in place, everyone within the org is actually empowered to do the right thing. We don't believe that we need to scale the company up to hundreds of engineers to be able to do this, right? What we need is we actually care about people who have architectural vision and product usability and care to drive the system forward. Once they're there, once they know what we're trying to build and do it, then multiple agents can happen at the same time. I have 5 agents running right now, this second, on my laptop. You know what I mean? And that's the way it's going to be. I truly believe that in the future of software, in this way, juniors become really important. Really important. Okay, because right now when juniors come into engineering orgs, they do low-level stuff. They like work on small pieces of code because you can't give them the system. Juniors now can learn the architectural constraints of the system. They don't need to care about the syntax of the code anymore. Sure, they can read it. Sure, it's really important for them to do it. But they actually learn at a faster rate about the constraints and systems thinking than they've ever done before. So for us, it's about making sure that we keep that core group of people who are actually entrenched in making sure that the user feedback is really good. I hear these questions all the time. I pre-created a bunch of issues. These are all questions I've had before, where look, like things like you judge 6 years of work, you threw it away, and you're happy with 4 months. This is the honeymoon period. Absolutely, 100%. Am I going to be like this in 4 months' time? I'll probably have redesigned the system 4 times under the hood. This is just the way the world works. Maybe I'll even do a bun-style rewrite it in Rust. I won't do that. But yeah, and we're learning a bunch. Anybody who has extra questions, come find me. I'll be hanging around for the rest of the day. Thank you so much. Enjoy the rest of the conference. It's been a pleasure.